we're going to look at, yes? We're going to look at primary trig ratios here. There we go. We've been given a question. This is from your homework last night. I took out the diagram, but this is the Skylon Tower at Niagara Falls. It kind of looks like the CN Tower-ish. A whole bunch of things. Okay, so the idea is this tower is 160 meters tall. That's pretty tall. Okay, so it's 160 meters tall, and we're going to say Justin is of some unknown distance from the tower, and he measures the angle of elevation to be 65 degrees. He then walks 20 meters farther and measures a new angle of elevation. What we're to do is we're to figure out what his new angle of elevation is. Okay? So there's quite a few unknowns in this question. First of all, we have two different triangles. These are not similar triangles. We have the first triangle, which is where he measured his first angle of elevation. The second triangle, the outside here, is where we really don't have a lot of information. I'm going to separate the two, and we're going to talk about what information we do have from each of them. So in the yellow triangle, and again, we assume the Skylon Tower is perpendicular to the ground. And what I mean by that is that it's a right angle to the ground. Okay? So the tower is 160 meters, and we have an angle 65. So we have two pieces of information, and because it's a right angle triangle, we can use either our sine, cosine, or our tangent ratio to solve any part of this triangle. We have enough information to work with this one. Our second triangle, which I'll put in blue here, try to exaggerate it a bit, we don't have a lot of information about. In fact, the only information we do have is that at some point he walked 20 meters, and we need to find this. Now, what we do know is that the other part of this triangle is actually the same distance as the base of our original triangle. So what that means is we need to figure out this unknown. I'll call this unknown A. Okay, actually we'll call it B for the base. So this unknown B we need to work with here. So we need to figure out what information we have. We have 65 degrees. And I need to talk about these angles. How are they in relation to this angle? Because we have opposite, hypotenuse, and an adjacent, we need to figure out what we do have and what we're looking for. This 160 would be considered what from the 65? That's right. This is opposite of it. Okay, so we'll call it our opposite. And our B would be what? Adjacent. That's right. So this is the adjacent side. Which means I need one of the ratios that deals with opposite and adjacent. That's right. TOLA deals with opposite and adjacent. So our tangent ratio. So let's set up our tangent ratio. Usually it's written as tangent, and I'm going to put a symbol called theta. This represents an angle. Okay? Is equal to our opposite over our adjacent. So let's take the information we do have. What angle did we have? 65. So we have tangent 65. Okay. It's equal to, what was the measurement of the opposite? 160. And what was the measurement of the adjacent? We don't know. We called it B. So essentially, B is our unknown. We want to find the distance of B. Now, because B is on the bottom of this fraction, this is how we went through our rules in chapter 6, I actually want to move the B over to this side in order to isolate it. I can't isolate it on the bottom, because if I move 160 over, I'll be left with 1 over B, and that's not what we're looking for. We're looking for just B. I don't want it as a fraction. So in order to move B over, what operation do I have to use? That's right. Because this is a division sign, I need to multiply by B. So I'm going to left with B multiplied by tan 65 equals 160. Now in order to isolate this B, what do I need to move to the other side? Tan 65. How do I move tan 65 to the other side? That's right. To come over, it needs to be divided because it was multiplied by b over here. So we get b is equal to 160 divided by tan 65. Now tan 65 is some number we'll put into a calculator. Oh, that's not a calculator. So we can bring that up. I wish. Tan 65. So 65 tangent. Where's tan? There it is. Okay. It's 2.144. So I'm going to rewrite it again. 160 divided by 2.144. Now, on many of your calculators, you'll be able to do this all in one shot, which is great because you'll be far more accurate. I'm not sure if I can on this one. Let me try. 160 divided by bracket 65. It didn't work? Oh, I messed that up. Okay. I'm just going to go with the number I have. 160 divided by 2.144. Nope, that didn't work. Thank you. That's okay. Divided by 2.144. There we go. So 74.6, we'll do a bit of rounding. We'll say that's 74.6, which is approximately, let's go the whole number 75. That's a fine estimate. Okay. So our base here is 75 what? That's right, meters. These lengths are measured in meters. So since we know that the base of this triangle is the other part of this triangle, I'm going to substitute that value in. So I now have a value of 75 meters. Okay. So in other words, our new triangle, what is the actual base of our new triangle? How do I figure it out? We got to add these together. So the 20 meters he walked after already being 75 meters from the base totals to 95 meters. Is there any other information we know about this triangle?
160.
What about 160? Yeah, we know the height of this is the exact same as the height of our other triangle. So that's 160 meters also. So we now have, and we're looking for the angle here, we now have the, what side would this be considered to this angle? Opposite and the adjacent. So the exact same information from before. We have the opposite and we have the adjacent. So let's set this up again. This time, though, we're looking for the angle.
Sir?
Yeah. So set this up. Tangent, what's our angle? X. We don't know what it is. Is equal to opposite. What's our opposite here? 160 over what's our adjacent? 95 meters. That's what we found from our other question. So now that we have that, and I can equate this if I want. I can just figure out what 160 divided by 95 is. And if you want to do it that way, that's fine. I'm going to leave it as a fraction. I like to work with fractions. This is the tough part. I need to isolate for x. So in other words, tangent has to move to the other side. When we move tangent to the other side, or when we're solving for an angle, we use the inverse. So it's probably the second function on your calculator. And it's going to look something like this. Tan to the power of negative 1. Okay? So you'll probably put these numbers in, 160 divided by 95, and then have to hit second function tan. So I'll show you what it looks like on my calculator. 160, so I take this value in here, divided by 95. So give me a decimal. And then I have the inverse tan. This is not inverse tan. This is tan itself. So I have to push inverse, and it changes the numbers on my calculator. And here's my tan to the power of negative 1. So I hit that button. I got 59.3. So x is equal to, sorry, I want to write that black. X is equal to 59.3, which is approximately 59. Now, is it 59 meters or? That's right, degrees. So let's, I know this is a little complex in here. Let's try to make sense of this. He was at a point where when he looked up, he had to look up at 65 degrees. Then he walked farther away, and his angle of elevation dropped. Does that make sense? The farther away he is, does he have to torque his neck up higher to see something, or not as much? Not as much. That's right. So if I walk farther away, I don't have to torque my neck up as high. If he had moved closer, let's say he'd moved this way, would the angle of elevation increased or decreased? Increased. The closer he gets, the more he has to look upwards to see the top of something.